Hi, this is Tom, and welcome back. Here we have our tree where for a multiple choice test of two questions, each question with three possible answers. Now, notice that only an answer of C was correct. So we're going to take the same test, but we're going to make a slightly different tree. So here we go. We're going to make a different tree for the same test, and then we'll compare what we found up above. Notice this, that if I have an answer of A or B, well, if I'm a student and I get my test graded, then those would be marked wrong. Whoa. Those would be marked wrong. But if I answered C, then it would be marked correct. So I'm going to use a C for a correct answer and a W for a wrong answer. And let's make our tree again. So again, we're going to take this test and we'll put our line up here. So we have question 1 and we have question 2. And that didn't come out right. There. So on question 1, I could answer A or B. But if I did either of those, I would get the question wrong. So I would put a W here. If I chose C, I would get the question correct. Now, let's take our second question. If you pick A or B, well, then you would get the second question wrong again as well. If, though, you picked C, your answer would be correct. Now, let's say you got the first one correct, and then you can, on the second one, you can either be wrong or you can be correct. Now, notice this, a few things. Right now, there's only, if I was to count this, there's 1, 2, 3, there's only 4 different outcomes in my sample space, but we know there needs to be 9. So where's the discrepancy? I'll show you. It's because when you answered correctly, the probability of that was 1/3, like we would expect. But now, let's put the probabilities back. The probability of getting it wrong wasn't 1/3, it was 2/3. And the probability on the second question of getting it wrong as well, well, that was 2/3. You could either get it wrong with an A or a B. The probability of being correct, well, that was 1/3. Again, the probability of being wrong on the second question was 2 out of 3. The probability of being correct is 1 out of 3. So now, just like in the problem above, we said that I could multiply these weights. So the probability of a wrong and a wrong, well, that's equal to 2/3 times 2/3. Now the probability of our next outcome, these are our outcomes, I could label those. The probability of getting the first one wrong and the second one correct, well, that is 2/3 times 1/3. The probability of the next outcome is correct and then a wrong. Well, that's 1/3 times 2/3. And our final branch of our tree is the probability of being correct on both questions. Well, that's 1/3 times 1/3. Now let's go through and multiply each of these together. So the first one becomes 4/9. The second one becomes 2/9. The third one becomes 2/9. And the fourth one becomes 1/9. Well, wait a minute. Let's think of it this way. If I was to add all of these up, I would add 4/9 plus 2/9. So let's write this out. The probability of a wrong and a wrong plus the probability of a wrong and a correct plus the probability of a correct and a wrong plus the probability of 2 being correct. Well, that's 4 ninths plus a 2 ninths plus 2 ninths plus 1 ninth. So 4 plus 2 is 6, plus 2 more is 8, plus 1 more is 9 ninths, which is just 1. And so look at that. Now we have the 9 in the denominator, as we would expect, and our fractions, again, all the probabilities add to 1. So now let's go through the same set of steps. The probability of getting a score of 0 out of 2, well, that happened, let's see, let's use the pink. The probability of getting 2 wrong was a wrong and then a wrong, and we found out that was 4 out of 9. So that's 4 ninths. Now, what's the probability of getting a score of 1 out of 2? Well, let's see. Let's use a different color for this. How about our light green? Well, I could be wrong on the first one and correct on the second one. That's one way. Or I could get the first one correct and then the second one wrong. And if either of those happen, I would get a score of 1 out of 2. So that came from the probability of a wrong correct plus the probability of a correct wrong. So that equals 2 ninths plus 2 ninths, which is 4 ninths. Now let's pause there and notice that we got, for just now, for 0 out of 2 we got 4 ninths, and for 1 out of 2 we got 4 ninths. Let's check with the work above. And there they are. You can see right here, here's 0 out of 2, we got 4 ninths. And, whoops, for 1 out of 2, we also got an answer of 4 ninths. So far it seems to be working. Let's try the last one, and that is the probability of a score of 2 out of 2. Well, that came from the probability of being correct. And we even have that one. That one is right here. If you take the bottom branch and then the next bottom branch, you get 2 corrects. And we already found that. That result is right here. That's 1 ninth. And so we can do that, 1 ninth. Now, if I give you a test that had 3 multiple choice questions, if I asked you to make a tree and make it the way we did here, you would have to deal with 27 branches. That's a big tree, and it would become so big that things would probably get lost and mistakes would be made. But if I asked you to make a weighted tree for a multiple choice test with 3 questions, well, in the end, there would only be 8 different branches. And that's a picture that's not so difficult to draw. And so that's why we use weighted trees to help us understand when the weights change, when they're not the same for every single piece. Then we can construct a weighted tree. And in the next video, we're going to practice some applications of this. Hope that helps, and thanks for watching.